Hi guys, welcome back. Next up we've got Jamie Lennox. Jamie works for Red Hat on the OpenStack project. So Jamie will be talking to us about JSON standards for the web. Yep, give it up for Jason. Sorry, give it up for Jamie.
Give it up for JSON. All right, welcome everybody. My name is Jamie Lennox. I work for Red Hat, generally working on the OpenStack project, and we're going to talk about none of those things today. We'll get straight to it because we're a little bit pressed for time. When I first proposed this talk, this picture had to be in it. It was about the first thing I knew about it, so I may as well get it out of the way early. I'm going to start out with a couple of disclaimers. There are hundreds of standards and helper libraries and best practices and other things whose aim it is to help make better quality REST APIs easily. And so there are whole sort of genres that I'm not even going to try and cover. My goal is to provide an introduction to a couple of them that I know or I've worked with and encourage you the next time you're writing an API or extending an existing one to go out and figure out what's already been done in the area rather than reinvent the wheel. There are also a lot of competitors for the couple I'm going to talk about. Some are better, some are better known, some are going to suit your project better. Use whatever works for you. I'm not going to bother with a REST overview. I think everybody here should have a reasonable idea of how that works. Hopefully everything I say about the standards is factually accurate. Everything else, complete opinion. Not like these are not the views of my employer, but like there are people who spend much of their life like debating things on forums about how JSON things should be implemented and how web APIs should be done, and they're probably all way more correct about these things than I am. Given that we're at PyCon, throughout the talk I'll sort of mention the Python libraries that can be used to do this stuff, but it's more about the APIs themselves rather than the libraries. Oh yeah, and if you're looking at an old version of the program, it might say something about JSON web encryption and JSON web tokens. We're not going to have enough time to get there, so I give you a chance to leave now if that's what you're looking for. All right, so flashback. The first web service I ever wrote was based in SOAP. REST was around, but it was even worse. Like, it wasn't as well understood even as it is now. If you haven't seen it, SOAP is an XML-based request protocol, and it sort of grew out of XML-RPC. And the protocol isn't pretty. It's enterprisey, it's maintained by a committee, and it spins together all of the nifty tricks you can do with XML. Initially, that S in SOAP stood for simple, and they ditched that really early on. But SOAP was popular for a reason. It was well supported by a bunch of languages, and every SOAP interface shipped with a WSDL file. And that WSDL file is a detailed description of all of the methods that the web interface can handle, including what the functions are called, what the parameters are taking, what types there were, what the types were, the errors that could be thrown, everything. So the reason I used SOAP was that I could construct a couple of functions in PHP, auto-generate a WSDL file, go over to Visual Studio, import that WSDL file, and have a completely auto-generated way of interacting with my web service. Now, I'm not proud of my language choices in those days. We've all grown since then. But in reality, that worked. And in the space of having never written a web service before, I followed a couple of tutorials on the web, and I had a well-functioning web service. And if it works, what do I really care about what that protocol looks like? So, and at the time, people understood XML a little bit better. You were used to working with it. And so there were really good tools for working with XML that just don't have a JSON equivalent now. JSON RPC exists. It's got a lot of the advantages of XML-RPC. There is JSON path, but JSON's easier than the existence of XPath is a testament to how hard it was to work with XML. And so JSON path not so necessary. XSLT is super powerful and absolutely horrendous. And there's a JSON T that was sort of, came out of that sort of standard. It looks a little bit like a Ginger template. And that was obviously taken way too far. because you may as well just convert back to XML. And if you think that's ridiculous, somebody came up with the opposite. So how to convert your XML into JSON. And I'm not trying to criticize those. It's not too hard to come up with a reason why they did that stuff. But the reality is JSON is an XML, and we need different tools for these things. But the goals we want with REST are very similar to those initial goals we had with SOAP. I mean, stateless requests, we just need that for scaling. Language and protocol independence, and open standards. And these are the basics of the web. Well, we wouldn't be talking about this at all without those things. But where SOAP had a real advantage is we want to be able to discover from the API everything you can do with the API. And if you look at the original REST thesis, it's in there as hypermedia as the engine of application state, or HATIOS. I think. I've never heard that said out loud to know how it's supposed to be pronounced. And the web had various opinions, so I won't say that again. Mostly it's referred to as hypertext anyway, and in its simplest form it involves, as part of your APIs you provide links. So how to get from this resource to actions that are on it, or from the base URL, how to find the resources. So the first of the standards. JSON Home is essentially it's a basic implementation of exactly that. It's a dictionary of relationships and the URIs of where you can access those resources. The relationships are unique, and each of these resource bundles has either a ref tag or a template and vars tag. So if you wanted to list widgets, you would go to /widgets, and if you wanted to get a specific widget, you would go to widget/widget ID, and it's got a very well defined what a widget ID is. So you're not going to get this wrong. And with this combination, you could theoretically rearrange your entire API, and a well-formed client would just follow the right links and never really know the difference. And as a bit of an early sidetrack, this one's not JSON, but it's a really interesting one. URI Template is actually an RFC, and it's a way to define links to other places and what parameters can be taken. So in the first one, obviously, you replace username with a real username to get that user's home directory. The second example there says it optionally takes a query parameter or a number parameter, and it does the right thing by, ampersand joining the pair of them if you provide both. And the second one, and the third one there is take any number of value equal attributes as attributes to foo. And they're very basic examples. That last one is a little bit more complicated, and where it starts to shine is the URI for a source package from PyPy. So enter any mirror, packages are separated by the first letter of the package, and I've no idea why they bother with that. But package, the first letter of the package name, package version, and if you use the URI template Python library, then you just provide these entries as a dictionary, and it will construct you that link. Where do I get this package from of this version? So back to this JSON Home. In addition to the ref link, everything has hints, and the hints are telling you things like the method, the formats, what you can post with, what you can patch with. And there's a JSON Home library which supports the basics of this, how to construct these documents, how to pull them apart, and query for specific relationships. So while JSON Home tells you all of the URIs that are available to you to an API, and the REST purist will tell you that's enough, because if you've correctly defined your MIME types, then you should know exactly what you can post to those things and what you should expect. But in reality, that doesn't work. So JSON Schema is a way to provide a contract. So how a strict representation of what can be posted to an API or what can be received from an API. So basic examples. The first one is a way of defining a validator for a string with a minimum length of 10, a maximum length of 14, and that regex, which should theoretically validate an Australian phone number. The second one will obviously take a true or false value. In the bottom left is a number, a multiple of 10, minimum 0, maximum 100, or a enum for red or green. And so they're your basic types. Where JSON schema gets interesting is when we start building up things a little bit more complex. So on the left there, we define an array. And in that array, we need to have at least 3 items. And they're all numbers of a maximum of 50. On the right, again, it's an array. But this time we've said the first element of the array is a number, and it's minimum of 1. The second element is a string. The third element is an enum. And obviously, street, avenue, boulevard. So this is a very, very basic way of specifying an address as part of an array. And additional items false, so anything additional to that array is going to fail the validation process. And where we get sort of where most APIs are going to be useful, we define objects. So an object that is accepted can have a name property, a phone property, and an age property. Again, nothing additional on the object or it will fail validation. And the name property is required. So Trevor of 44, that'll pass. Age of 44, failure because it's missing the name. And Trevor providing his leg seam will fail because we don't want to know that information. Like, it's not relevant to us. Once we start getting more complex, we can do things like definitions. So I can define ahead of time that this is how I define an address. And then the actual validation of this object is the bottom part, which is, again, object and properties, has a billing property and a shipping property. And both of them are addresses. So reusing some of that information. And on top of that, we can start doing things like combining definition. So that first entry will validate either a string or a number. Top right is anything but a string. And this bottom one is an interesting way of essentially doing inheritance with JSON schema. By doing all of, we say that this object that we're validating must match both an address that we defined earlier and have the property of address type, which is either a residential or a business. So there's cool ways you can build these things up. But I guess we get to why. I mean, all of these validations we could have done in code. And the first advantage is using your code as documentation, or maybe your documentation as code. Once you've got all these JSON schemas, you should publish them. Like, put this in your documentation, and it's a very strict, this is what I accept from this API, and this is what I return. And any clients you have are there, then really know exactly what you want for each of your calls. And I guess secondly, this is where I think things start to get interesting from like a tooling perspective, because in a JSON sense, we now know everything that can be done with this API. So I guess I'll flip over to, hang on, let me mirror this briefly. Kidding, it's going to freeze. All right, looks like I'm doing things over there. This is going to be weirder than... All right, so basics. This is Vim. If anyone heard of the resume.json format, it's a little bit of a hipster idea of you should construct your resume in JSON, post it up to this website. It knows, because it's a well-structured, it's got a JSON schema and stuff, it knows everything that can be expected. And post it up and it can render it in different ways, and you should be able to search for things and whatever. That's not really the point of most standards. But this is a well-defined schema. So at this point, I can, all right, the basics. I know when I have a name, I have an email. Yep, I have a website. So, sweet. I don't know, what else can we do? All right. And you can see that there's some description up there. Education, yep, That makes sense. It was an array of object. Yeah, okay, so I want that, want that, want that. Oh, no. Okay, and these are the things that are acceptable under the education for this particular JSON schema. Whether you use this to construct your JSON resume, I don't really care, but I pulled this off of a site which is, I think, schemas.net, which is a repository, and there's only about 50 of them there at the moment, but well-defined, well-known JSON schemas. And there you can find things like project.json and a whole bunch of other things that people will interact with and use on a fairly daily basis if you're doing these things. So that's kind of cool. All right, I can see that being useful. What about, if we know what is expected, we can do something more interesting. So what about, this is my JSON schema for how is my talk going. It's fairly basic. You could post it to a form. All right, well, it seems silly if I know what's expected that I'm going to have to write that form. So let's do, this is going to be a really good effect with 2 screens, and it didn't work. Why don't I start auto-generating my forms? So this library is called alpaca.js. And if I flick back to this is the schema that's used to generate this talk. Flick over to the index. All I've done, imported some JavaScript, some handlebars because, and I've defined a button, and I've defined alpaca. It loads my schema. Options doesn't have much in it. It says that feedback should probably be a large box rather than a small text box, but there's nothing really revolutionary going on there. And that's it. So, am I advocating you use this library rather than write your own forms? Maybe not. But if you're looking for something basic, that's really quite cool. Like, if you're prototyping, if you're doing things quickly, that's a great idea. And as you can see, this field is not optional. These fields aren't optional. And if I give it a name, I'll give it a meh. And save it. And it's constructed me something that is going to be validatable by my JSON schema if I post that to a website. Oh, it's going to start me again. So this feels like a good time to stop in and mention this. You've probably seen this phrase before. It's known as Postel's maxim. It's be conservative in what you send, be liberal in what you accept. And that's coming out of RFC 1122, which is IP, like Internet Protocol. So, and it was around even before that in some of the earlier drafts. So we're talking historical, really, in the sense of the internet. And it sounds good. When you're writing a client, you should be really careful and only send up what you know is going to be accepted. And when you're writing a server, and the client makes a small mistake, you should go, that's okay, I know what you meant, and sort of paper over it. And don't. It's time to let this one die. So this first site that's linked, it's not the first or the only criticism of Postel's maxim, but I particularly like this one because rather than ranting on a blog post, he submitted it as a draft to the IETF. So when you allow these differences in a standard, then you end up with drift. As these small changes in implementations become relied upon, and eventually you just end up standardizing all these small changes in the implementations just to keep things working. Otherwise, you're sort of stuck with only being able to work against one proprietary situation, and we've got no benefit from that as a community. So not even from not a standard, if you're writing your own APIs, following this makes backwards compatibility nearly impossible. you start modifying code, and it's like, well, I still strictly adhere to what I said in my documentation, but I changed the response a little bit. There's going to be some client that relies on things happening exactly that way, and you've broke them. So, yeah, it's dying. It's gone. Fail fast and hard. So as soon as you know, all good? As soon as you know that something's wrong, quit and exit out hard. Like, this is something wrong, and at least that way your client application is going to catch it in development. It's not going to break them later on in some weird way. And as you add future things, you can reuse that space and without having to worry that somebody's relying on you. So coming back to some of the JSON schema stuff, there's a bunch of libraries out there that can generate JSON schemas for you. I picked JSL for this because it's framework agnostic. If you're using Flask, there's a Flask one. If you're using Django, there's a Django one. There's one for SQL Alchemy, so converting your models directly into JSON schema. There's one for Marshmallow if you're serializing things that way. There's a lot of these things. But this one's fairly easy to see what's happening, I think. Everyone see what's happening? Quiet. OK, so you've got an entry. You subclass it with file. So a file has a name and a content. A directory has it's either a file, it's an array of either a file or other directories. So a directory structure. And if you get schema, you will get a valid JSON schema. Similarly, from the client side, you can take an existing JSON schema and create like self-validating classes out of it. And I guess I show this one because now we've got the server side, the client side, and we're almost at the point really where SOAP was about a decade ago. With server side and client side working together and trying to take some of this load off the developer doing things manually. Attributes are validated at assignment time, so you're pretty sure at the end you're not going to have, well, you're pretty sure at the end what you have is going to be able to be posted to your API. Again, there are a couple of libraries that do something similar to this. Actually, one of the things I like about Warlock is that it has JSON Patch integration. So I have that. And this is JSON Patch. You start off with an object, you apply an array of patches to it, and you end up with a new object. Obviously, there's a couple of operations: replace, add, remove. I think there's a move and a couple of others. The path there is that format of /baz is called JSON pointer, if you're looking for it. And it's kind of like a subset of XPath. So /baz is a key in the root called baz. But the advantages of this is, I mean, anyone coming from a database sort of background will see the advantage of this. You've got a write-only transaction log of how an object changed over time. You can do merges much more reliably. You can do auditing of who did what change much more reliably. There's lots of cool things that you can do with JSON Patch. And the pip library, the Python library, has creating patches, so taking two dictionary objects and creating a series of patches that gets from one to the other, and it has application of patches. Now, just because there had to be, rather than have those two separate standards for hypertext and JSON schema, there is an extension to JSON schema called JSON hyperschema. It's a completely optional addition to JSON schema, and it hasn't had quite the adoption rate of JSON schema. And I've left off any particular mention of a package because there's a few around, but I haven't really seen one that does a great job of this. So the idea is that's still a base schema object, but where I said earlier about delivering links and using hypertext, the interesting part about JSON hyperschema is it delivers the links from resource to resource in the metadata, in the schema. These links aren't being handed down on the request. When you validate it, you've said this is a valid object based on my schema, and therefore I know these links exist. So better, worse, I don't know, but it's kind of interesting. In terms of comparison to JSON Home, it's really missing a lot of like the methods and what can you post to and what methods does it accept and things like that. I hope that no one came specifically for the JSON API stuff. The talk was just going to run way too long. I described how you find the URIs that are acceptable on the server. JSON Schema will give you what the definition looks like, or how to define what your responses and your bodies are. JSON API is a way of a standard body. And there are a lot of these. JSON LD, collection JSON, HAL, a bunch. The thing I really like about JSON API is there is a way for the client to specify what it wants from the server. So I had the example here of an article. In JSON API, as a client, I could say, in addition to the article, just give me the author. Like, give it to me now. I know I'm going to need to render this. But take that away from the server. Have the client say, I want that author to be included. And I want that author's other posts to be included, or whatever you need from a client perspective. So I hope, as further reading, if you're interested, it's a long spec, but it's quite an interesting one. Coming to the end, I hope you learned something, a standard you hadn't seen, or a library you hadn't seen, or something useful. A couple of finals, don't go overboard. There are hundreds of these things, and you cannot combine them all into the one document. It will just end up a mess. But conversely, if you're going to make an API or you're using an API, have a look around, because there are hundreds of these things. And even in specific use cases, there's specific how to represent different statistics in JSON, how to represent geographical areas, how to, everything. So don't reinvent the wheel. Have a look. The more we can reuse the standards, the better the toolings become, the better you can reuse existing libraries, and it just becomes more easy to use. And I guess finally, this was about some of the technologies I think are cool. But I barely scratched the surface. There are probably better ones out there. You should research any of these before you ever thought about using them. If you find something better, then you should come and present on that next year, instead of me. And that's it. That's me. I work for Red Hat. They're always hiring. That's my pitch. Cool. Thank you.
All right, we've got enough time for maybe one or two questions. Yep.
Hi. I guess my thought is in Python it's very easy to write code that just gets the variable if it's there and reverts to a default if it's not there, as well as it doesn't mind if there's extra variables in an array that you don't care about. So that example with the leg seam, and it should fail because you provided something extra. I guess there's two schools there. I have seen Java libraries specifically that fail very hard if you give them too much data. But if you do allow people to add extra information, you can do version 1.1, 1.2, 1.3 as any new data is... Now, any added data is a non-breaking change, whereas if you remove data or change types, that's a breaking change.
Yep.
What's your thoughts on that?
I think in general the client knows what the server is going to use. I mean, if you're expecting to post up, say, user information and the user, it doesn't exist yet in that version of the API, I would want to know about that. Not that this information came in, but sorry, we ignored it because we don't know what that is. And once you start if you ever need to get to the point where you add that later, you start getting conflicts of, maybe somebody has, I guess this is sort of like proprietary extensions. What happens if people camp on each other's namespace? What happens? My opinion is, if you don't know what it is, just quit out, because in general, that's what the user wants. If they've given you that information, they want something done with it, and if not, they want to know that it's not being done. Personal opinion again, but I say if you don't know what it is, just fail.
Yeah, some of the elements you mentioned in the schema, like properties required, are this like known standard, or is it like particular to the application or specific which you mentioned?
I can't actually see where that is.
Here.
Oh, right. Hey. Sorry, some of the elements for...
So in some of the schema examples which you mentioned, like the properties of the schema, the elements of the schema, like required properties. Is it like W3C standard, or is it like specific to your application?
So in this one particularly, everything in that root is either required or optional. So the things that I've added to that are the properties. So, you know, I can define properties to be whatever I like. And as I said, I've made up name, phone, and age, but everything in that root is a well-known key. JSON schema knows what properties mean, and it knows what additional properties are. And I don't actually know what happens if you give it extra stuff in that root. But yeah, it's well known.
Okay. In one of the slides, if you go to a few of the slides starting initially.
Which way?
Starting from the start. Somewhere you mentioned enum,
yeah, bottom right is enum.
So you mentioned type is string and enum as well. So are those both required? It's only the enum.
I think the enum would be okay on its own. I would need to double check the standard, but I'm pretty sure the enum would be okay on its own, because there's no reason I think you couldn't define an enum that took some strings and some integers and something else. So I would expect this, as specifying both type and enum, to do two separate validation steps. Hope that answers the question.
Okay, that's about all we have time for questions. We've just got this mug as a thank you. These mugs, man, seriously. All right, let's just thank Jamie again for his talk.